So we talk about two different frictional forces between two surfaces, in this case between this wooden block and the table. There is the static friction force. This simply resists the force with which I'm trying to move this block. There's a frictional force countering the force that I'm pushing on this with. And then kinetic friction is the force that's resisting while it's moving, and those are different. Now static friction can have different values, right? If I push on this just a little bit, the static friction force that's resisting it is the same as this, not very much. But the harder and harder I push, the more the static friction force becomes until it kind of breaks free and moves. Now it's this maximum friction force that from which we'll derive the coefficient of static friction. That coefficient gives you the maximum static friction force that a surface can exert. Not any frictional force, but the maximum one, so right as it breaks free. And the way we're going to measure that is using this force sensor. As I push in here, the computer measures the amount of force with which I'm pushing. And as I start the measurement, I'm going to push on this a little bit, and push a little harder and harder and harder, and all of a sudden it breaks free, and then I can move it at a constant speed. Now, the coefficient of static friction, I'm going to stop this recording, the coefficient of static friction is higher than the coefficient of kinetic friction. So as the force increases, as I pushed it harder and harder, the force increases until you get that maximum force that the surface can exert on the block, and then it breaks free, and then the kinetic friction is fairly constant. So it's this maximum value of the static friction that you'll use to derive the static friction coefficient, and then sort of the average value of the kinetic friction that you'll use to derive the kinetic friction coefficient. So here's an example of the kind of data you're going to use. It looks a little bit confused, but I think you should be able to make sense of it. This is multiple runs of the same kind of thing that I just showed you, with increasing amounts of weight on the top of the wooden block. So this is 1 kilogram, 2, 3, 4, 5, and 6 kilograms. So for instance, on the 4 kilogram run, this is the peak of the static friction where it broke free, and that gives you about 18 newtons of resistive force. And then here is the average value, which is, say, something like 13 newtons. So something like that. So that's how you're going to use this.